I present to you Professor Tony Pipe, the Deputy Director of the BRL. Tony has 35 years of experience in advanced technology systems integration, gained from working in industry, academia, or collaborations of both. He's deeply involved in a number of Innovate UK funded connected autonomous vehicle projects with a total value exceeding £30 million. In short, Professor Pipe is a master of self-driving vehicles. Here to tell you more is Professor Tony Pipe. Welcome to the stage.
I actually wrote that, so I didn't realise it was going to get all read out. But nonetheless, I am one of the deputy directors of the Bristol Robotics Laboratory, and it's a laboratory invested in by both universities. Is the logo? Oh dear, that's the wrong button. There's the logos down there. There's the University of West of England and University of Bristol, and the BRL logo. So I'm from the University of West of England, but there's an opposite number, deputy director from the University of Bristol. So, as it said on the introduction thing, I do spend a lot of time working on autonomous vehicles. I'll go through some of the projects briefly in a minute, mostly from the highlights of them. I'm also involved in other stuff, but that's not relevant for now. So, in terms of just a quick one slide introduction to the laboratory itself before I get on to other stuff. There's the Bristol Robotics Laboratory and all the things it does. Those are its themes, or in little bubbles around it, and the logo. And the things that are marked in either green or red, either indirectly or directly, contribute towards a kind of area that we're currently most interested in right now in autonomous vehicles, which is ensuring their safety and usefulness. Of course, you can probably imagine that if I'm interested in other robotics as well, then a fair amount of what I'm interested in there is also translatable across to other domains like assisted robots in care homes, in manufacturing domains, in human robot teams, and so on and so forth. In other words, the safety and the usefulness is critical. And in fact, one of the words which is linked with safety and usefulness and that is hard to define is an issue of can we make robots in these environments worthy of our trustworthy? And that's actually a really complicated issue, which I only have time to just flit across the top of in a talk like this one. I only have 15 minutes. I was going to say, I said to some people down the front there, my standard talk time is 2 hours, so I'll do 15 minutes and someone will have to start yelling at me, okay? So we also work with another group, also in the group of two universities, trustworthy systems for understandable reasons, bearing in mind what I just said. So let's just get back into autonomous vehicles then. So some of you, it depends on how familiar you are with this field, a standards organisation called the SAE, it's an American standards organisation, but it doesn't really matter, who came up a while ago with 5 levels of automation, and they're a bit disputed as to what they mean. So this is somebody's interpretation of them, but generally speaking, 0 means there is no automation. 1 or 2 is what is currently available on the market. You know, things commonly called ADAS, Advanced Driver Assistance Systems, so automatic braking, preventing skidding, lane control warnings, so on and so forth, intelligent cruise control. My car actually has, it's only a VW Golf, but it has intelligent cruise control on it. So that takes you up into, in the upper ends of that, into level 3, where by the time you get to level 3 automation, you might have an intelligent cruise control that you might be able to enable it to overtake other cars on the motorway, for example. Rather than just reducing to the speed of the car in front, you may enable it to overtake. But up to level 3, and including level 3, it's all really about the technology, because it's still the standard insurance and legal situation. Whether you are actually physically driving the vehicle at that instant, you are still completely responsible for it. In other words, there's somebody in the vehicle who's notionally the driver. They're still looking out through the front windscreen and paying attention to anything, so they could take control at any moment. Once you get to level 4 and above, if you press a button to say it's in autonomous mode, you're not responsible anymore. And that has both technical, obviously, implications, but also legal and insurance implications. So that's the area that car manufacturers and others are dancing around at the moment, because clearly it has huge implications for the manufacturers, the insurers, the people, the car dealerships, who would be responsible if there was an incident. And there already have been some incidents in experimental land and even on real roads, not in this country. So what we actually mean by level 4 or level 5 is a little bit under dispute, but you could say it's one or both of these two things. In a level 4 vehicle, you're very likely still to have a steering wheel and brake pedals and so on, and accelerator pedals, so that you could take control if you wanted to, but if you press the button to say you're not in control, you are now have passenger status. Whereas when you've got to level 5, there probably won't be any more a steering wheel or brake pedals and so on, so you wouldn't be able to take the same level of control even if you wanted to. Another slight slant on level 4, level 5 is what degree of road complexity is a vehicle able to cope with. So they're quite closely coupled. In other words, it's quite likely that if you're in a level 4 vehicle that's got a steering wheel and brake pedals, it's something that you're predominantly using that autonomous mode in simpler to handle environments like motorways or dual carriageways. Although forward speed is fast in those circumstances, they're relatively safe environments and they're very well signposted. So sensors like cameras and so on find it easy to find road signs and so on and so forth. If you go into the most dangerous example is a 2-lane country road where you might have a upper speed limit of 60 miles an hour. If there's another car coming the other way that you collide with, there's a 120 mile an hour collision, there could easily be fatalities. And in those circumstances, road markings disappear and come back again, could due to dirt and just usage. Foliage gets in the way of signage, so on and so forth. Those things will remain difficult to handle for a very long time into the future, I believe. So you could say that level 5 is kind of also going into that area. Okay, so a sort of a general time scale, and this is a fairly slightly out of date diagram now, but I like the fact it's got some examples of what they mean here. So possibly by 2030 or so, there might be a level 5 vehicle around. But I can qualify all that, if you like. That was a thing that was written, as you can see from the timescales down the bottom left-hand corner. It wasn't written in 2010, but it was somewhere like 2015 that diagram was made up. I didn't make it up, actually. I just thought it looked kind of interesting that it has actual names of things that may be in place. But since that time, things have become a bit clearer in terms of how it might be that vehicle autonomy might first enter the marketplace and which others might be later. So, 2 steps. Not sure what's going on there. That's it. So I'll just quickly allude to the 6 projects that we have been involved or are still involved in. These are all Innovate UK funded, if you're familiar with that funding body. So they're close to market research and they're all led from industry. So we are partners in it, but they're led from industrial partners. And the thing that's changed, we were actually in Venture, which was the first of those, now finished. The bias was much more on replacing the human being in an individual car. In other words, how would we make an autonomous system to replace the piloting that you do? In other words, you subconscious control that you do, keeping the car in the right place on the road, knowing that you need to start braking a certain distance before some junction or other. You do that without even really thinking about it once you've learned to drive. And then also the conscious level reasoning, the decision-making system, as we would call it, which is the more conscious driving experience you have of deciding where to go next, or whether you should overtake this car or not, and so on and so forth. So Venture was predominantly about that, and also about the technology. We were heavily involved in developments of some of the technology at that time. This is early 2015, and we're the first people in the UK to have a car on the road. It was a converted Land Rover, so it looked more like a lorry, but it was a car. We still have that vehicle. But we were also interested in user acceptance and the impacts on insurance and legality at that time, because the whole situation was a lot less known then. And then gradually, as you go through these projects, and I haven't got time to go through the details of them, the flavour gradually changes, as I've shown on the right-hand side, from individual vehicles to groups or systems of vehicles interacting with each other and with manually driven vehicles and the infrastructure. In other words, it becomes a kind of a swarming type of problem. There are multiple vehicles that can communicate with some of them which can communicate directly with each other over wireless communications. They can also similarly communicate with the infrastructure, the roadside stuff. They might be able to tell what, and possibly even influence the states of traffic lights and so on and so forth to smooth out traffic flow. But mixed amongst them, at least for a while and possibly forever, will be people manually driven vehicles. And that is a difficult interaction, I'm sure you can imagine. So I ride a motorbike, by the way, so I know if I'm coming to a minor junction, I always make sure I can see the eyeballs of the car coming the other way. They've seen that I'm there, whereas how to do that if the vehicle's autonomous? Anyway, so there are ways of thinking about how to do that, but not immediately obvious. So they terminated the project that's only just started quite recently, in which a bus will drive in autonomous mode across the Forth road bridge in Edinburgh as a fee-paying concern. And so if I use that as a kind of allusion to what I think might come first, well, as I probably mentioned to you and kind of made reasonably obvious, full level 5 autonomy for a private vehicle is going to be hard to do, especially on those rural roads. Motorway driving may come autonomous mode for fixed periods, and relatively short periods may come in fairly quickly. The car manufacturers themselves are kind of ready for that. And it isn't useless, because if you think about it, quite a lot of the things that go wrong on motorways are due to people losing their concentration because something's happening in the vehicle that they need to attend to. You know, the CD's finished, finding the next one. Your children are arguing in the back and you need to pay some attention to sorting them out, so on and so forth. Something's dropped onto the floor and you could really do with picking it up from the bottom of the floor on the pedestrian. So those kinds of things are often the sources of accidents on motorways. And if you were able to put it into a kind of intelligent cruise control in which it also steered and stayed within the lanes for, say, up to 40 or 50 seconds, that's not useless, because it allows you to spend those 40 or 50 seconds finding the CD or whatever it is you need to do. Okay, I think that could happen relatively quickly. Another thing that could happen relatively quickly is low speed vehicles, and especially what we would call in this country pods. They're also called RPTs, rapid transport. Oh, yeah, I've got this wrong. No, PRTs, private rapid transport systems. In other words, small vehicles that might be able to do 20 or 30 miles an hour on public roads in urban situations, but also go into some pedestrian areas. There's no such vehicle type currently in existence, I mean legally in existence, in the world. I don't think anywhere. There are various experiments going on, and 3 out of those 6 are associated with pods. And it's a angle which is of great interest in the UK manufacturing sector, because it's a new vehicle type that they could see if they could take an industrial lead in. We work with 3 different companies who are possible manufacturers of pods, which range from 2 to 4-person vehicles. So they're predominantly level 5 vehicles. There's no steering wheel. You may not even be facing the direction of travel. Let me show you some pictures of them, sorry. So bottom left is a Westfield pod, and bottom right is an Origo pod, and the middle one is just a vehicle we created ourselves from a Renault Twizy, which is actually a road legal vehicle, but is pod-sized, which is quite convenient. If you want to take the thing to a demo, you can drive it there on the roads first. Whereas the vehicles on the bottom left and bottom right are not yet road legal vehicles. They're also not legal for driving in pedestrian areas, but clearly it's an aspiration. The other vehicles that we're looking at there is a couple of buses. As you can see, there was a bus involved in the first project we were involved with called Venturer. The stagecoach bus in the middle is a typical example of the kind of bus that's going to drive over the Forth Road Bridge in Edinburgh. The top right is the converted Land Rover, which is the first vehicle that was driven on roads in the UK autonomously. And the drawing, actually that's not real, of the small van is a company called Arrival, who have arrived rather recently in the UK and are interested in providing electric and possibly autonomous vehicles to deliver parcels. And that's a project called ROBOPILOT, which you may have noticed I just went past. Okay, so I've got 3 minutes, I think. Did I start late? No, there's no chance of that. No, worth a go, wasn't it? This is a little demo thing from. Maybe I can't make this work. Let's try that. Okay. Yes. Sorry, the mouse wasn't there before. Sorry. Yeah. Your magic finger made it. This is the Venturer project. Was the earliest of the projects.
The Venturer project is the first driverless car project to start in the UK. It's a 3-year research and development project based in the southwest of England.
Today we're conducting trial 3 of the Venturer project. We're looking at interactions between the autonomous vehicle and road users such as cyclists, pedestrians. The main objective is to find out about how people react to sitting in or watching an autonomous vehicle interacting with these other road users, and also we're interested in observing the technology working itself.
So it's much more looking at what we call the human factors or the social impact. The pedestrians and cyclists are observing those scenarios and they're rating their trust in the autonomous vehicle.
I have to stop at that point because we're going to run out of time otherwise. This is the next slide. So this is a more recent project. This is in the project ROBOPILOT. You may have noticed that's the Arrival van that you saw a picture of earlier on. So here we've been taking a gradually greater interest in simulation because it seems clear that simulation is going to be a really critical part of the introduction of this technology from about 3 different viewpoints. One, there's type approval of vehicles themselves, new vehicles. If you look at the Google car, for example, I believe it's done 5 or 10 million miles, something like that. If you look at how many millions of miles you would have to drive on even motorway driving in order to prove that your vehicle was safe, in other words, in this many million miles you can say, I've come across enough, I will have come, just by statistically, enough events to show that this vehicle is safe, you'd have to be doing something more like 200 million miles. That is a long way away from 5 or 10 million miles. But you could do a lot of that in simulation, and simulation obviously has the advantage that you can make dangerous things occur more often than they would by chance by just driving around on the road for hundreds of millions of miles. That's one use of simulation. Another one is that how on earth will an MOT, the equivalent of an MOT, work when what you want to be testing as much as the mechanical stuff, which of course is still relevant, you also want to be testing whether the AI is still roadworthy. Is this still a safe vehicle to drive on the road? You may well have to do that in simulation. And that becomes really scary if you include machine learning in that, which a lot of the manufacturers would like to have. In other words, the vehicle gets better at driving as you own it. But that means it will be different from one year to the next when you test it. Ooh. And then there's drivers themselves. If we are using autonomous vehicles, we'll become a lot less experienced at being manual drivers in the circumstances where we need to take control. And in fact, the whole idea of you having to take control in some emergency situation is new and scary anyway, because human beings are not especially good at doing that. There are a fair number of not so distant aircraft disasters that show examples of human beings not being amazingly good at taking over control in emergency situations. So you might want to actually be testing for that on a regular basis in human beings, perhaps every year or every 5 years or something. Okay, anyway, so simulation is rather important, but there are a load of questions about what kind of simulation, at what level of accuracy do you need to be simulating. And you also need to build the maps. This is the map from the CAV-Forth project, which is the one, if you see the Google style red dot at the top there of the screen, just before it there's some water, and that is the, whatever river it is. That's the river going one part of Edinburgh to the other part of Edinburgh is the road bridge. What river is it? Oh, never mind anyway. So this is the Forth. Thank you. Of course it is. Sorry, yeah. This is the... I just said it earlier on, didn't I? This is the centre of Edinburgh down here, and that's the outskirts up there. There's actually a park and ride up at the top there. So the idea is this autonomous vehicle would drive from one side to the other in a circuit. So here are some questions about early use of autonomous vehicles. So as I said to you, public service vehicles, i.e. buses, pods, or personal rapid transport. Heavy goods vehicles in convoys, possibly. You could devote, the inside lane of the M6 or something to be autonomous lorries between 1 o'clock in the morning and 5 o'clock in the morning or something like that. So you just have to know as a manual driver of a private car not to go in the inside lane. Parcel delivery. So notice that the public service vehicles and parcel delivery and some of the applications of pods could well be in areas where there's a fixed route, and that's why it's easier to do. You can imagine that if you don't have a private vehicle could be driven anywhere that road vehicles are allowed to go to, so you'd have to make it safe in all of those possible circumstances. Now, there's plenty of complexity on a bus route or for parcel routes. You might go around delivering parcels, but at least you know where the vehicle's going to go beforehand. You can know some things about the road conditions. You can have run round that fixed route several times before as a kind of test for roadworthiness of the vehicle. It's kind of a place you could get to first. And possibly detailed manoeuvring of large vehicles like lorries in where if you're sitting in a large heavy goods vehicle trying to reverse onto a construction site or similar, it's actually usually end up with another person behind you telling you, yelling at you, or using a walkie-talkie to tell you how to direct the steering and all the rest of your vehicle. Wouldn't it be great if you could press an autonomous mode and then say where you wanted the vehicle to reverse into and it just did it for you? Thank you.